Welcome to the session number 6 from the playlist of Assertion and Reasoning. That chapter is Electric Charges and Fields, and the topic is the electric flux and the Gauss law. So, based on this topic, I have taken one question for this session, and here the question has got two parts, the assertion part and the reasoning part. And there are four options given here, so we have to choose the right option. So the assertion here is the electric flux which is emanating out and entering a closed surface are 10 to the power 8 into 10 to the power 3 and 2 into 10 to the power 3 voltmeter respectively. So this is the flux which is emanating out of a closed surface, and this is the value of the flux which is entering a closed surface. So the charge enclosed by the surface is equal to 0.053 microcoulomb, and the reasoning is given as the Gauss law, or you can say the Gauss theorem, can be applied to verify this assertion. So we know that the flux which is passing through a closed surface is given by the Gauss law or the Gauss theorem, which says that the flux which is passing through a closed surface is equal to Q divided by epsilon naught, where Q is the charge enclosed by that surface and epsilon naught is the permittivity of the free space. The value of the permittivity of the free space is equal to 8.85 into 10 to the power minus 12 farads per meter. So this is the value of the permittivity of free space, and so in this question we have to find the charge which is enclosed by the surface. The value is given here, that is equal to 0.053. So what I will be doing is I will be using this Gauss theorem in order to find the charge enclosed by the surface. So Q will be equal to epsilon naught into the flux which is passing through this closed surface. Now we also know that the electric flux which is emanating out of a closed surface is taken as positive, and the electric flux which is entering a closed surface is taken as negative. So the total flux which is passing through this closed surface will be equal to 8 into 10 to the power 3 minus 2 into 10 to the power 3. So this is equal to 2 into 10 to the power 6 into 10 to the power 3 voltmeter. So this is the value of the flux which is passing through this closed surface. So the charge enclosed by this closed surface will be equal to 6 into 10 to the power 3 multiplied by 8.85 into 10 to the power minus 12, and this will be in coulombs. So if I multiply this 8.85 into 6, the 8.85 into 6, so this is equal to 53.1 into 10 to the power minus 9 coulomb. So this is the value of the charge which is enclosed by this closed surface. So here the answer in the assertion, the charge on the charge enclosed by this closed surface is given as 0.053 microcoulomb. So I will just try to write this value in terms of microcoulomb. So Q will be equal to, what I am doing here is 53.1 into 10 to the power minus it is 9. Now I will be just multiplying this value by 10 by 3, and I will be dividing this value by 10 by 3. So this value and this value is the same. So this is equal to now 10 to the power minus 9 into 10 to the power into 3, this will be equal to 10 to the power minus 6. And if I divide this 53.1 by 10 to the power 3, this will be equal to 0.053 and into 10 to the power minus 6 coulomb. So the charge enclosed by this closed surface is equal to 0.053 into 10 to the power minus 6 coulomb, or this can be written as 0.053 micro coulomb. Okay? So the charge enclosed by the closed surface is equal to 0.053 microcoulomb, and since this reasoning is supporting the assertion, because here they have written that the flux which is emanating out and entering a closed surface is equal to 8 into 10 to the power 3 and 2 into 10 to the power 3 voltmeter respectively, and the charge enclosed by this closed surface is 0.053. So in the reasoning it is written that the Gauss theorem can be applied to verify. So we have used the Gauss theorem in order to verify the amount of charge which is present inside this closed surface. So this reasoning is supporting the assertion, or now this assertion is correct, this reasoning is also correct, and at the same time this reasoning is supporting the assertion, or you can say this reasoning is the correct explanation for the assertion. So the option will be here A. So A is the correct option in this case. So thank you very much for joining this session. In the next session, I will be taking up a different topic from the same chapter of electric charges and fields. So till then, have a nice day. Bye.